I am going to present you one PPT, which is actually the fundamentals regarding the solar PV system, solar PV design. It is the fundamental about the panel. It is the fundamental about what is cell, what is panel, what is array, what is string. How can we connect the panels in series and parallels? That is according to our requirements, and also some of the a little bit design and the maintenance of the battery, maintenance of the inverter, maintenance of the panel, something like this. So from here, it is the diagram from cell to array. So this is one cell uh, which is capable of deliver 0.5 volt, as you know, though it is the silicon solar cell. So when this cell is connected to some series and parallel arrangement inside the panel or inside the module known as the module, and the modules, when they are connected through some series and parallel, they are known as the panels, and these panels, when connected according to our requirements, then it is known as the array. The array is arranged in parallel as well as in series, that is according to our load, according to our desire, or according to our requirements. So here you can see the inside the panel, these are solar cell bus bars and these are cell fingers. So this is inside the panel. So how the cells are arranged in series and parallel inside a cell. This is the circuit of the cell. Now this is the structure of the solar cell. This is the structure of the solar panel. So in the above there is a frame, and just below the frame it is one glass is there, that is known as the tempered glass. You know the tempered glass is in your mobile, and this is the encapsulant, then solar cell, again encapsulants, then backsheet and junction box. So another important thing is one ethyl vinyl acetate is most commonly used encapsulant materials. EVA comes in thin sheets which are inserted between the solar cell and the top surface and the rear surface. To protect the solar cell, we should use encapsulant, and that is known as the EVA, ethyl vinyl acetate. As a result of which, when your panel drop down, then it will not hot to anything else. So here exact the arrangement of the 60 cells to be the output of a 30 volt. So it is 60 cell solar panel. The cells are connected plus minus in series, and though it is one cell is 0.5 volt, so we can say that the 60 cell of a panel gives us 30 volt for this panel. So it is the backside of the junction box. So it is the backside of the junction box. One bypass diode is here, because in the night time the battery from the source, the energy can never be go out. This is conducting strips. The strips are there. The bypass diode terminals, this is the terminal, and connections for PV cables. These are the slots for connection of the PV cables, and one cover is there for waterproof cover. So here another important thing is that PV module with 3 bypass diodes dividing the panel into 3 strings. A large leaf is shedding one cell, causing the current to bypass one of the string as indicated by the green arrow. Suppose some dusts are there, suppose some unwanted things are there, then there will be a shadow effect. So as a result of which your panel will work through the bypass diode. So in such a way the diodes are connected that we can never obstruct the solar energy which can be used for storing the battery. So here are the examples of the bypass diodes. So this is the technology regarding that bus bars, how bus bars working, the fingers working. You know, these are the fingers and this is the bus bar. When your current will flow in this way, then it will go through this bus bars, and you know that width of the bus bar is much more important. The width is greater than the fingers. So because when the electrons are flowing through the fingers individually, then they are collected, and by the help of the bus bars they are gone through, so that the bus bars are more thicker than that of the fingers. The width of the bus bar is much more greater than the width of the fingers. Now then come to the point semiconductor. That means the upper side of the solar panel is negative electrodes, and the below lower side is the positive electrodes. So when the sunlight radiates or falls on the panel, then the electrons will be excited and they will be ready to move from this side, and the electric current will flow to the regulator, and the regulator will convert your DC signal to either boosting upward or boosting downward by the help of the charge controller or boost converter or boosting systems. Then it will go on to the battery storage system, and after that we will be able to use that power. And here you can see the series or parallel combinations of the some cells. Here you can see here a 100 watt, 18 volt and 5.56 ampere. This is the short circuit current, this is the open circuit voltage, and this is the wattage of the panel. This is a single, this is single, this single. So it is 100 watt single. So when two panels are connected in series, then we will calculate the power. Total power is 200 watt and the voltage is 36 volt, because when some cells are connected in series, then we can calculate the voltage will be added and the current is same. In case of series connection, just like the cells, the panels are also like that. When two panels are connected in series, then their power will be added as well as voltage will be added and current will be the same. But again, when these 100 watt panels are connected in parallel, then what happens? The current will be added and voltage is same, and also your I mean to say that the power will also be added. So these are the connections are in parallel. But the last figure shows you that two panels are connected in series, then two panels are connected in series. After that, this 2 into 2 means these two are series, these two are series, and they are connected in parallel, so that your voltage will added and the current will same. So this configuration is much more important to design a plant, to design whatever it may be. It may be a 1 kilowatt load or below 1 kilowatt load or above 1 kilowatt load, but it is much more important how many numbers of panels are going to be connected in a series, how many numbers of panels are going to be connected in parallel. So that is a much more important thing. As you know that our Snyder lab also runs through the solar power. So our backside of this above building, we are arranging the system in such a way that we can control 1 kilowatt system in our lab, as well as we also able to charge two batteries of 150 ampere hour connected in series. And also some of the systems, some of the appliances in our lab are connected in series with parallel combinations. That's why the power generated by the solar panel feeds to the battery and easily liable for the expense. So there is not the possibility of the choking hazards. So in this connection, you must have to know the series and parallel combinations of battery as well as the panels. And after next class, I will explain you how much minimum current, how much minimum voltage can required to charge how many number of batteries that can be connected in series and parallel. It is a formula. But we are not going to design arbitrarily. 4 batteries are there, 10 panels are there, and we are connecting arbitrarily them. But it is not the perfect way to design. So there is some formula behind that. How much current, minimum current required to charge the battery when the panels are connected in series and parallel. And if the batteries are connected in series, then what is the minimum voltage to charge the battery, what is the minimum current to charge the battery, so that these are all the things which should be known to you. Okay, so going for the next slide. So this is the how solar cell, this is the working principle. You can see here how solar cell is working. Here you can see the battery is connected to the panel. Here you can see the battery is connected to the panel. So the electrons are flowing through this way. When the switch is off, now the switch is off. When the switch is on, then bulb will glow after some time. Just watch it. The switch is on, then it is glow. When the switch is off, then it is off. And it is the IV curve. As you know that we are calculating the IV curve of a simple crystal diode. So here it is nothing but one diode. So here we can be able to measure the current, measure the voltage at different times in a day. Then when we plot the graph, then we will get somehow a linear output. You can see here, current and voltage is linear. When the voltage increases, the current also increases. So up to a optimum point, that is the maximum point. This is the maximum point. At this point, it will drop. At this point, it will drop. So just one logic you can put. Suppose this is the point which is starting from 0. So let it be at 8 a.m. So from 8 a.m. to let it be somehow it is maximum, that is 12 noon. So from this point of view, when the voltage will increase, at that time radiation will also increase, so you will get a more current. So when voltage will rise, then current will also rise. So at a certain point, you will get the maximum power here. So when you draw the curve, then you will get the maximum power here, and after that it will fall in this way. So in the evening when there is no sun, so at that time you will get the maximum voltage, which is the battery voltage, and you will get the current will be 0. So at a certain point you will get the maximum current and voltage. When you multiply the current and voltage, you will get the maximum power at that time. So this is the practical oriented things. When you measure voltage and current, then you will get the maximum voltage, maximum current at a point, and you will calculate the P max, that is maximum power, and that is optimum, and which is known as the maximum power point tracker, maximum power point tracking, and you will get that. So this is nothing but the IV curve. So now let's have discussed about the blocking diode and bypass diode. As you know, blocking in the sense the reverse current will not go backwards. So blocking diode is much more essential to prevent the reverse flow of the current at night from the batteries to PV modules, as they do not produce any voltage. As you know, it is very clear to you that in the night time there is no radiation, there is no generation. So at that time it is the possibility that the reverse current from the battery will flow towards the panel. So for that reason, if there is no diode connected in the panel, so at that time you must have to arrange the diode through the battery. But nowadays, or the panels which are manufactured, at that time they connect the blocking diode inside the junction box of the panel. So there is no need to connect blocking diodes again. And another is bypass diode. As you know that when there is a shadow effect, then your panel may not be working. So at that time, you have to connect your strings or few cells in the panel are shaded by bypass diodes, provided an alternate path for the current to flow from unshaded area, bypassing shaded panel or portion which has high resistance. So this is nothing but the basic idea about blocking diode as well as the bypass diode. Now, this is some advantages and limitations. Limitations of solar power or solar power plants. देखो, advantages is reliability, durability, maintenance cost low, no fuel cost, noise free operation, modularity, safety, independence, electrical grid decentralized. But it has some limitations. देखो, here it has been written low maintenance cost. It is obvious, but it is high initial cost. Definite. As you calculate, as per your, I think, off-grid system, you must have calculated the value of the solar panel. So as you know that for 1 watt, it costs 35 to 40 rupees. So that if it is 100 watt panel, so definitely it will be 4,000. So if you are going to design a 32 kilowatt power plant, then you must require 100 number of panels of 150 watt. So let it be, if one panel is somehow 150 in the sense 6,000, then 6,000 multiplied by 100. So you can imagine how much cost is the panel is there. Then another thing is that battery. So we are using here 100 number of batteries, 80 number of batteries, 40 in series, 40 in series, then in parallel. So you can say that the batteries are 200 ampere hour. One battery costs somehow 11,000 or 12,000. So you can imagine that one battery if costs 12,000, then 80 number of battery, how much cost. Then two PCUs are there. They are not inverters, they are PCU, power conditioning unit. So one power conditioning unit of 16 kilowatt is nothing to say or worth saying. That is above 1 lakh. So another important thing is that your wiring. So it is also a great factor. So initial cost is high, but after that, though it is maintenance cost is low, reliability, durability, no fuel cost, noise free, modularity, so that it is safety and independence and electrical grid connects, decentralizations are there. So that we can say that if initial cost is high, then after that there is nothing else for cost designing, only maintenance is there. Then another limitation is seasonal variations in solar radiations. As you can see that our panel facing to the south, so that when there is a solar and lunar variable of the sun, then we will be put in trouble, that much more radiations we will not get. So at that time, somehow our generation will be less. So somehow if you design the plant, then it should be a prominent thing that it must be in ground level, not in rooftop. So in ground level, if ground mountings are there, then you will get a much more efficiency rather than the rooftop. Then energy storage, as you can say that where to store the energy. If it is a off-grid system, if it is a net metering system, then you must have your energy storage batteries like that. If it is grid tie, then there is no need for that. But if it is off-grid system, whenever there is no power from the grid, then we will use our solar power. Then it is much more important, much more required for energy storage. So batteries cost is high. Then efficiency improvement. We can improve our efficiency because gradually your battery capacity will decrease. Then educating the user. Educating the user means it is the limitation things. As you are technical students, as you are qualified students, and as you are a good students, so you may be able to understand everything. But if you design this plant in somehow illiterate areas like let us consider about Sarada, that is in Sambalpur district, and they are not known about the panel, about the battery, about the lighting and something like this, and they should have to educated about this. So educating the user is much more important. So this is the advantages and limitations of the solar power plant. As you are your internship is focused or based on this solar, so that you must have to know about the advantages and limitations of these things, because in your course the design, the maintenance, the troubleshooting is more important. So now we are moving to the next slide. So this is solar irradiations through the day. So intensity of the solar radiation is watt per meter square. Solar energy received by the earth surface is kilowatt per meter square. So we must calculate kilowatt hour per meter square. So commonly use the terminology that is kilowatt per meter square per day or kilowatt hour meter square per year. Then standard sunshine hours, that is 1000 watt peak or kilowatt hour per meter square. So this is the graph. This is the graph of some a particular area and through the homework software. Acha. Then comes to the storage system. Storage in the sense battery system. So types of battery, you know that. So different types of batteries are there, but you come under lead acid battery as well as your that means in your lithium ion battery. So these two types of battery you know, but in spite of that, there are different batteries are also there. So first, lead acid battery. So this lead acid battery divided into some of the flooded lead acid, then sealed maintenance free. This sealed maintenance free also divided two parts: valve regulated lead acid and absorbent glass mat. Then lithium ion. And another battery, latest advancement battery, that is hybrid ultra capacitor, zinc oxide, dry cell, hybrid combination of the above technology. So these are all the battery systems are there. Next, this is the tubular lead acid battery frequently used in your home for the inverter. And this is sealed maintenance free. This type of batteries actually are used in our that ever say car, scooter, bikes, and lithium ion battery. You know, these are all the lithium ion batteries. And this is ultra capacitor batteries. And this is zinc manganese dioxide battery. And this is the lead acid plus lithium ion hybrid types of batteries. Actually, this type of batteries are commonly used in power plants. Sorry. And then lead acid, the advantages. Actually, the lead acid battery is somehow 200 ampere hour is more than 10,000. Still, it is low cost. Because all other batteries, all these batteries, lithium ion, lead acid plus lithium ion, lead acid, and zinc manganese, these batteries are more cost than tubular lead acid. So that advantages of this is it is low cost, and its lifespan is somehow it is I think if it is well maintained, then it will cross 10 years. Definite, it will cost 10 years. It is the practical experience of mine. It is the practical experience of mine. One lead acid battery, 150 ampere hour, 12 volt. That is now running his life 11 years. One battery. Expired its warranty, expired its guarantee. But still the backup is somehow 6 hours per day. Because it is well maintained. Then it is recyclable. Recyclable, you can also do that. It is easy to recyclable. It is easy to recyclable. You can dismantle the cabinet of the battery. Then you can be able to wash that and change the liquid. Then it can be recycled. So reliable and low self-discharge. Self-discharge is very low. if it is the full charge of the battery, that is 12.69 volt, then if you keep the battery for a month, then definitely it will discharge, but it is self discharge is very low. So limitation is also there. Regular maintenance required. Low energy density, that is poor energy weight ratio. According to the weight of that battery, the energy is very low. The weight somehow it is definite, it is 20 kg above. So according to the weight, if you calculate, then it has the poor energy. So limit to rate of charge or discharge. When you charge it and when you discharge this battery, this is the limitation is there. Some cycle is there. Then poor voltage stability, high internal resistance. Definite, it has the high internal resistance because inside it some hydrogen sulfide is there, some liquid is there, and we pour the distilled water. So definite, the internal resistance must be high. Then it is ventilation required. If you keep this battery inside your room, then it is very much dangerous for your safety. So definite there should be the ventilation is required. So next, these terms are related to the battery. It is much more important. This should be known to you very well. That is battery capacity, days of autonomy, rate and depth of discharge, life expectancy or life cycle, specific gravity, then efficiency, environmental condition, then maintenance schedule. These terms are more related to the designing. Though solar panels are not required any type of maintenance frequently, but your storage system, battery system must require this type of things. So you must have to know the terms related to the battery. So one by one we will go. Dekho, what is ampere hour? All of you know that in your battery you will get 100 ampere hour, 20 ampere hour, 10 ampere hour, 80 ampere hour, 60 ampere hour, 200 ampere hour. But what is that ampere hour? Ampere hour is the unit of the battery energy capacity equal to the amount of continuous current multiplied by the discharging time. That means when there is a discharge, so continuously it will happen, and it will definitely depends upon the time. With respect to time, it will discharge. So that should a battery can supply before exhausting its internal store of chemical energy. Then CX rating. So rating of the battery. Battery capacity is also specified as a function of time in which it takes to fully discharge the battery. That means 100 ampere hour battery, C10 rating. So battery capacity is 100 ampere hour when discharged in 10 hours. That means at the rate 10 ampere. So if you say that it is a 100 ampere hour battery, so at that time you have to focus what is 100 ampere hour. That means current 10 ampere and it will discharge in 10 hours. So when ampere and hour is multiplied with each other, then we can say that it is the ampere hour. So 100 ampere hour battery and rating C10. That means in 10 hours, 10 ampere current will be discharged or consumed from your battery. So that according to, if we calculate C20 rated battery, then you can say that in 10 hours, 5 ampere current will consume, or you can say that in 5 hours, 10 ampere current will consume. So that according to your current rating system. But in our power plant designing system, we must have to use C10 rated battery to accumulate or charging and discharging of the battery will be synchronized. So it is the general formula for continuous current in amperes, that is ampere hour rating for charge or discharge time in hours. Then charge or discharging time in hours, it is ampere hour rating with respect to continuous current in ampere. That means why it is continuous current? Because the current will not discharge from the battery from time to time on the time lagging. it will continuously discharge with respect to time. Then it is another thing, depth of discharge or state of charge. It is one of the much more important things for you. So what is depth of discharge? Depth of discharge expressed in percentage is the shape level or specified by the manufacturer to which battery could be discharged, beyond which the battery might be damaged permanently. Acha. One thing is that in your mobile, when your mobile shows a percentage of a red, that means if your battery discharge and level comes to 20%, then there will be a red mark. So at that time we can say that you have already used 80% of your power. Only 20% is remaining. So that you can say that depth of discharge is 80%, and at that time how much power is there? 20% power is there in the battery. So that is known as the state of charge. That means at the particular point, how much charge is stored in the battery, that is known as the state of charge. So if the state of charge is 20%, then the depth of discharge is 80%. If the state of charge is 30%, then the depth of discharge is 70%. So here you can see state of charge when 100%, then a 12 volt battery will show 12.6. As it is the practical aspect, you have already seen in a full charge battery, the voltage is 12.6 or 12.7. So as per voltage per cell, that is 2.12. So when the state of charge is 90%, your voltage will decrease to 12.5% and the voltage per cell is 2.08. So when it is 80%, then voltage will decreases to 12.42 and voltage per cell is 2.07. So that comes to the 40%. So 40% to 80% or 80% down to 40% is the green level. So at that time, your battery will work 11.9 volt and per cell is 1.9. But below that, it may not work. So when it comes to 30, 20 or 10%, then you can say that when your state of charge is 0%, then your battery level is 10.5. So 10.5 means that there is no power in your battery. You can never use. So here another diagram, SOC versus Diode. When SOC 100, Diode is 0. When SOC is 80, then Diode is 20. When Diode is 80 and your SOC is 20. So this is the calculated value of one battery. What is depth of discharge and what is state of charge. So this is the cycle of life or life cycle. So battery life cycle is defined as the number of complete charge discharge cycle the battery can perform before its nominal capacity fall to 80% of its initial rated capacity. That means we know that when battery is discharged, automatically it will charge. When it is automatically charged and the full of charge, then we will use that battery. So this is the running cycle. So how much cycle continuously it will charge and discharge, that depends upon the manufacturer, that depends upon the battery, and that depends upon the types of battery. So this is nothing but the life cycle of the battery. So key factor affecting cycle life are time and number of charge discharging cycles completed. Next is the specific gravity. It is defined as the ratio of mass of the specific volume of electrolyte. So how much electrolyte hydrogen sulfide inside the battery to the mass of the same volume of pure water. So that is the ratio. We can say that if one of the volume will less, then definitely it will affect on the specific gravity of the battery. Then efficiency. Efficiency we can calculate ampere hour, we can calculate also watt hour. So if we calculate ampere hour efficiency, then discharged ampere hour into 100% divided by charging ampere hour. If we go for the watt hour, then discharge watt hour by charging watt hour into 100%. This is the exact formula of the efficiency to continue, efficiency of the battery. So here is another thing, that is battery autonomy. Autonomy in the sense that is the backup time. How much days it is going to back up, how much time it is going to back up. So autonomy is the length of the time which a battery bank can support a specific load without overcharging. The value used to measure battery reserve capacity and system reliability. So type of used in off-grid system design, that is inverter system 2 days and a DC system 3 days. I will show you, I will explain you about that inverter system how 2 days and DC system 3 days later. So one example is there. Suppose the battery requirement for a daily energy requirement 40 ampere hour. With 2 days autonomy means actual battery capacity 100 ampere hour. So that 40 ampere hour into 2 days plus 20 ampere hour, that means 20% capacity which cannot be used. We can never use. Just for one example, you know that when there is a reserve in your bike, when there is a reserve in your bike, so in case of Hero Honda Passion Pro, the amount of petrol, that is 1 liter 200 ml. So we can use only 200 ml. So 1 liter can never be used. So that is the actually 20% of the capacity we can never use. If we use, then battery will damage, definite. So that don't restart your inverter in your home when there is a signal from your inverter. When the backup is completed, then you can say that 20% energy is stored in the battery. So if we restart our inverter, then it will be very bad effect for your battery. So 20% capacity we never use. So why autonomy is needed? Autonomy enables the system to perform as required even under monsoon season, cloudy conditions for specified days of autonomy. So enhances battery life, that is the depth of discharge versus life cycle. So next, it is the important, estimated battery life under various autonomy conditions. So generally, with the autonomy factor is varies from 1.5 to 3, 1.5 days to 3 days. According to it depends upon the load factor. So this is all about the panel and battery. So in the very next class, we will discussing about the controller, inverter, and other things.